Thank you, MC. Very good day to everybody. I'm really excited today to share this talk on going wild with rice. I shall talk about wild rice later to keep the suspense. It's very important for us to safeguard our wild relatives of cultivated crop plants in gene banks or in the wild. Rice, okay, I think everybody knows what rice is. Rice is actually a staple food, and we all love rice. Some of us eat rice 3 times a day, 2 times a day, or once, and there are those who eat maybe only 3 or 4 times in a week. So rice is a staple food in Malaysia and Asia. It's actually we have actually more than 50% of the developing world consuming rice. And rice is actually not only a carbohydrate source, it's rich in nutrients, vitamins, minerals, and an excellent source of complex carbohydrates, depends on how it's taken. On average, rice contributes to about 24% total daily energy intake as a main source of carbohydrate. And rice comes in various types. It can be characterized or given brands depending on the grain length. It can be short, medium, slender, or long. And rice can be have fragrance or no fragrance. We all know how some of our Malaysians love fragrant rice, jasmine rice, or the basmati rice. And rice can be consumed as a polished rice or as unpolished rice, that is with the bran and germ intact. And rice actually not only is white, we all know rice is white, but like milk. But rice can have different colors, and these colors come from the bran or pericarp, which is pigmented, or we call it pigmented rice. It can be red, purple, or even black. And rice can also be fortified with vitamins and minerals, or where we can breed it to have increased iron content, or even vitamins like vitamin A, like golden rice. Okay, here you see the slide showing how rice is enjoyed by many people with the various side dishes, and it can be savory. Mostly all is savory here, with a good source of nutrients from vegetables. So the ideal diet is actually the half of vegetables and fruits, a quarter of protein, and also a quarter of carbohydrate. Okay, today I'm going to tell you about the complete rice that we have developed from research that has been done in collaboration with research institutes and also universities led by UKM. The rice is a low GI antioxidant rice, and the variety that has been registered as a new plant variety is UKM FAScinate. So we developed this crossbred rice from wild rice, which is a wild relative of cultivated rice. And this rice is actually available now in the market in more than 1,200 outlets, retail outlets. The rice is farmed in Kedah and Perlis, and is accessible to all of us to purchase and enjoy it. And let's take a look at the goodness of this brown rice or unpolished rice. Okay, the foremost, actually the top benefit is actually the surprisingly low glycaemic index of this rice, which is about 46 on a scale of 0 to 100. So when GI actually helps to stabilize your after meal blood glucose levels, and it is actually a ranking of carbohydrates, as I mentioned, from scale of 0 to 1, 0 to 100, sorry, according to the extent to which they will raise the blood sugar levels after eating. And foods that are high in GI are rapidly digested and absorbed, and they result in marked fluctuations in blood glucose levels. And this is a problem if you have compromised insulin production and unable to control your blood glucose levels. So you get a spike, as you see in this graph here, the green one. High GI food, you can get a spike, and with low, you don't have a spike, and this actually helps in the heart health. Okay. The other benefits of this rice is rich in antioxidants, as the color is red, and the red color comes from anthocyanins, which gives a red color. And as you know, anthocyanins are a good source of antioxidants, not only to reduce risk of cardiovascular diseases, through reduced inflammation of blood vessels, but also antioxidants are now considered as anti-aging too, because it helps you keep younger. And this rice is rich in fiber, which is quite high. The fiber is 2.7 times higher than normal rice, about 4.5. And it makes you feel satiated and not hungry fast. So you will consume less of this rice when you are consuming it with the other side dishes, which helps you also indirectly reduce your calorie or carbohydrate consumption. The rice is rich in zinc, and as you know, zinc helps to boost immunity to viral infections. So it is a good source, natural source of zinc that you available in this rice. The rice, when we tested the rice for GABA, which is gamma aminobutyric acid, it was high, very high actually. So this rice, when it's sprouted, you can see the small radicals there, which emerges after you soak the rice for 6 hours and you leave it overnight. After overnight, then you can see it sprouting. And we measured the GABA and we found it to be very high. And this helps to reduce stress and anxiety. So it's a good source of rice, GABA rice, for especially children and adolescents. The rice is rich in RS, or resistant starch. And resistant starch, as you know, helps or influences functioning of the digestive tract, especially the microbial flora, the blood cholesterol level, and also the glycaemic index, and helps together with the low GI. This is actually the contributing factor to the low GI, the RS, which is high. Okay, let's look at rice. As we know, there are more than 24 species of Oryza sativa, but only 2 species are cultivated, which is indica and japonica. And there is another subspecies of sativa, which is javanica, which is not cultivated because of its poor fertility. So the dendrogram here, based on the molecular markers, microsatellite markers, 30 microsatellite markers, show how distinctly different they are genetically, the subspecies, which is indica, japonica. Japonica also, they have japonica, tropical japonica, which is grown in tropical regions, and temperate japonica. And aromatic, also aromatic rices, and also the aus, which is also mostly cultivated in Bangladesh. So, okay, have a look at that. And now I show you how different these rices, the 2 cultivated subspecies are from the wild rice. Wild rice, we have about 22 wild rice. You know, you have rufipogon, Nivara officinalis, which is found in Malaysia, 3 wild rices. And then you have many more, Minuta, many more species that are also found, and they have useful genes. So they are quite distinct, but you can see that some of them are more closely related to indica, some are more closely related to japonica. And the wild rice that is most closely related to our cultivated japonica and indica is Oryza rufipogon. So this rice, it becomes very useful when it wants to do improvement, because it has many beneficial alleles and many traits, but it also has many negative traits also, which needs to be removed or not selected. So wild rice here generally is tall. You can see the plant. It sometimes can be 1 meter usually, or more than that, to 3 meters. And it is, hulls are black, long and slender. And they also have awn. That means they have like a protrusion from the grain that is sticking out, which facilitates for dispersion. Wild rice actually has 2. One is from Oryza, which is a non-cultivated Oryza species. And then you also have wild rice from Zinzania, which is actually cultivated in North America as a wild rice. And those are the one you see in the middle, the long grains, but it's very hard. Here in Malaysia, before we embarked on the study how we can introgress the wild rice genes into the cultivator to improve the yield, we looked at the diversity of the Oryza rufipogon found in Malaysia. So here we show all the accessions, that is plants that were collected from different parts of Peninsula in the northern part. And we found that the diversity is very wide, and it can form about 12 groups here to show here. And one of the accessions which we used in our introgression program was closely related to MR219, which means the rice has already gone through introgression. Okay, more on this is actually published in our work in Topical Plant Biology, as you can see here by my master student, Mu Missing. So, besides, you have on one side the wild relative, but how do we use it to improve through breeding? So the technology that is used to expedite breeding is actually molecular marker technology. And molecular markers, there are many types. So generally, these markers are actually, they represent the genetic differences between individuals or a species. And they are very useful for selection and to expedite selection. So normally the marker of choice for this QTL or quantitative trait loci is markers that are very polymorphic. And we have multiple alleles at one locus and easily can be scored. And the marker of choice normally is the microsatellite marker or the single nucleotide polymorphism or SNPs. So here is a diagram showing how markers can be used. So the closer it is to the QTL, which is the trait that we are selecting, then it is very useful for improving. Okay, so here, so we have the markers, so we need the breeding strategy to do this. And if you are using distant relatives, like in the case Oryza rufipogon is considered a distant relative, we have to do backcrossing. So in backcrossing, there's the two sides here on this figure. On this slide, on the left is the conventional backcrossing, where it's based on phenotype. And on the right-hand side is the marker-assisted backcrossing, where it is facilitated using molecular markers. So the marker used here is microsatellites. So it facilitates precise selection of individuals, one verification of the progenies, whether it's F1 or BC1, and precise selection of the progenies. So you can see that the selected BC2 progeny has got the minimum number of donor genome, which is the useful genes, and then it has the majority of the genome is coming from the recurrent parent. So whereas in the case of the phenotype, you really do not know. You have to go by phenotypic selection, and you can also wrongly select. So they ended up selecting 3 plants. Here you select only 1 plant or 1 family. So this actually saves costs in terms of further screening. So if you have markers, you can expedite. Okay. So in our study, where we did the hybridization and introgression, that is called the advanced backcross breeding, or we call it ABQTL. We use rufipogon as the donor, and the particular accession is called IRGC 105491, crossed with MR219, which is our mega variety in 2000. But unfortunately, this variety is no longer grown, because for rice, varieties need to be released every 5 years, and usually they can last maximum 10 years if for a good variety. Some don't even last for 3 seasons or 2 seasons. So here we did the crossing. You can see very clearly, one is a red pericarp, the other is a very pale brown pericarp. Okay, those are the unpolished. And we produced the F1. F1 is looking more like the Oryza rufipogon, the panicle. You can see there, showing the panicles. And also, and as you forward, selfing, further backcrossing and then selfing, you can see segregation taking place. This is part of the laws of segregation according to Mendel's laws for different traits. So you got different, you get black horns, black hull, long with horn. You have black hal, no on. Then you get a golden with on also, and you have golden grains without on. So we need to do selection. Okay, so those are the numbers of individual families that we screen. The numbers are there, tally with the different generations. So from this advanced backcross, we managed to construct a quantitative QTL map or quantitative trait loci map to pinpoint where the traits are, or the genes that are governing these traits, where are they located in the chromosomes. Rice has 12 chromosomes, so you can see the 12 linkage group here. And you can see that the ones in red are the good ones with high significance. And we focused on one of the, QTL, which is grain weight QTL chromosome 6. And grain weight QTL chromosome 6 was used for further backcrossing and to develop new isogenic lines, that is lines containing only the gene, fine mapped to, if I'm not mistaken, about 150 kb. Okay, so then these new isogenic lines are now available and stored in the gene bank in MADI, and it can be utilized for improvement of any variety where you has got the traits, desired traits, like a short duration, short plant height, but the yield is not good. So we can improve the grain weight of it. Okay, so once we have got the map and then we got the material done and done the selection, we actually have to forward it many generations until backcross of generation, say 8, F8, to homogenize, to make sure that the plants are uniform and stable, and there is some distinctiveness in terms of their traits. So we have to produce breeder seeds, which is a continuous process, and also foundation seeds are produced and provided to farmers, and so that they can produce high quality rice, which will give us the high purity also. So now going to the problem. So once you have a product in hand, farmers would like to plant it because it has got higher yield compared to other colored rices, and the price is higher for the farmers. But how do we market the product into the public? So now we know in worldwide, we have this increased lifespan because of good medical care and also good environment. We have our lifespans have increased, but we need to make sure that even if we live longer, say more than 75 years, we need to have a healthy life. We are not sedentary, we are not immobile, and we can still move and enjoy the good things in life with activity and also having a good family life. So, and these diseases are mainly lifestyle diseases, or we can also call them as non-communicable diseases, or NCDs. And this study on disability adjusted life years done recently shows that unhealthy diet is the highest risk to our lifespan, reducing our lifespan. And unhealthy diet actually contributes to diseases like diabetics, hypertension, and okay. So the food, as I mentioned, dietary risk, the food that we consume can be categorized into two, according to the disability adjusted life years. High risk is bad, low risk is good. So high risk is the food that is, you can see all the fast food there, local food or even any food, fast food. And quick to, maybe storage wise and availability is easy, but it's high in sodium, also very sweet. And also we can put the white rice also as under the high risk daily food. In low risk live food is our balance, which we need to make sure our meals have consist of this, which is whole grains, fruits and vegetables, nuts and seeds, and also good seafood, which has got good source of omega-3 for heart health. So whole grains I want to focus, since we are consuming a lot of whole grains as our staple food, and it has to be good quality. So if you look at Malaysia now, rice that we consume Malaysians, you will be surprised, we consume 2 million metric tons a year on an average of 60 to 80 kg per person a year. So our rice, we are not self-sufficient in rice production yet. We import 20 to 40% imported rice, and 60 to 80 is produced locally, depending on the years and depending on yields. Okay, so they will do this to make sure that we have enough rice. So, but we find that there are 4 categories of rice there. We consume mostly white rice, followed by fragrant rice, basmati rice 1% only, and the colored rice is very, very low, below 1%, 0.1 to 0.3. So we need to switch slowly. Say if you're taking 2 meals a day with rice, maybe 1 meal you have to take a whole grain, or certain days in a week you take more whole grain than compared to white rice. So switching to the whole is actually the ideal situation for have a healthy lifestyle, which means that the choices for the whole include red rice, brown rice, you can have brown rice, black rice, or purple rice. So we can now then, if you keep to stick to this, you can help reduce the burden. Actually, not only we can be healthier, but the burden on the government for provision of medicines and healthcare related to NCDs. Okay, so the key messages that I would like to deliver is actually 4. First is we need to use genomic tools or bioscience technology tools, genomic tools, in complement with conventional breeding to accelerate crop improvement for future security or food security. That's very important. There are other technologies like artificial intelligence and also machine learning, which can be utilized, especially in surveillance of diseases or even nutrient deficiencies that can be utilized using drone technology. So that's another tool in the cultivation part when material is already growing in the fields, in large fields. So that's one way. And the second message is actually we need a very strong academia industry partnerships for successful deployment of whatever technology that we are using and the biological resources that Malaysia actually is rich in that. So we need a good partnership, and this partnership must start from the beginning of the research so that it's easier for absorption by the industry. And researchers actually should be trained or become familiar with the needs to translate their research to the market. They should understand, besides having their main objective actually is to publish very good high impact factor articles in journals. So that's second message. And the third message is actually, I showed you earlier our study on genetic diversity of the Oryza rufipogon. This was done intentionally to understand what is the genetic diversity of the wild relative. So it's still fine, but we actually make a very clear point that this wild, we cannot take it for granted because it's growing mainly in the canals and also abandoned rice fields. And if you keep increasing the cultivation, the genes from the cultivated species can flow or cross into the wild, and the wild doesn't become wild anymore. It will be already have a introgressed with the cultivated. So in situ, ex situ conservation of wild relatives is important for any crop species, not only rice, and for rice is even more important. And in situ means you're growing in managing the ecosystem well, and ex situ means in seed bank or field gene banks. And the other important message is actually sometimes is silent. We take for granted. If we don't conserve our ecosystems, whatever that is in the ecosystem, the species which we cannot see, especially the microorganisms, They help to ensure healthy soils or fertility of soils. So, and also the animals that we see, like the insects, they play a big role in terms of ensuring health of the ecosystem, or the what do you call it, the lands that we are cultivating. So we need a good balance between biodiversity and land use for agricultural purposes or other development. Okay, I think these are the 4 main messages that I want to share from this presentation, besides focusing on how we can utilize wild relative of rice to improve yield and also health, which has got health traits. With that, I will, here's a slide showing some of my students, my PhD students and my collaborators from ERI, from Bangladesh Rice Research Institute, and also the figure down is actually from UKM and Mardi, where we jointly do the work together. So we need good collaboration, and with shared facilities, we can have shared prosperity. Thank you.